to start out today, I'm in a calculus class right now, and I'm having trouble with implicit differentiation, so I thought I'd make a video about implicit differentiation, and maybe I'll learn it a bit better. So let's get right into it. Alright, so there's a couple of things we need to know to start off. Differentiation just means finding the derivative of something. And when you're finding the derivative of something, you're just finding the slope. So like, if you have a curve, let's say, like something like that, I don't know, and let's say at this point here, the slope of this line at that specific point would equal its derivative. Yeah, I'm not going to go super into that right now. Okay. Alright, so basically, implicit differentiation is when, alright, well, so you got explicit and implicit. And then implicit. So basically what explicit differentiation is when you have a y that equals an x. So both of these would exist at a point. But for implicit differentiation, what you kind of have is you end up taking the derivative of y, and what happens is y, so dy dx. What you have here is dy, which is so you don't have anything in relation to itself. So you can't really. So when we find x, we can find x because it's in relation to y. But when we want y, we don't know what y is. So what you end up doing is, let's find an example problem here. So we want to find the tangent line at x squared y5 equals 4y squared minus 3x. Okay, and then we're given a point, which is just an ordered pair. I don't even know if you can see that. Again, that's still kind of difficult, but I'll go with it. Okay. Alright, so we've got x squared y to the fifth, 4y squared minus 3x. So step one, what we want to do is we want to take the derivative of each side. So, and then use I think that's the product rule. I might have certain. Yes. No. Yes. Okay. So you can use the product rule here, and then the addition and subtraction rule here. Okay. So product rule, addition, subtraction rule. So we can take 2x. Oh no, hold on. So clearly need more work. Okay. So we take x squared multiplied by the derivative of y to the fifth plus y to the fifth times the derivative of x squared. And that equals d dx of 4y squared minus d dx negative 3x. Okay, boom. So then, oh, there you go. So we got x squared, and then you just take the derivative like a regular x would, so you get 5y to the fourth. This is the key point though. You multiply by dy dx plus y5 multiplied by 2x. You get this. And then d dx of 4y squared is going to be 8y times dy dx minus the derivative of negative 3x, which is just move the 1 down, plus 3. Okay. Alright, so I'm going to sit down here. This is kind of low. So, yeah, I think we can still see decently. I don't know. I'll take it. Alright, so x squared 5y to the fourth dy dx plus y5 2x equals 8y dy dx plus 3. And then what we want to do, we're going to figure 1, 1. So you get 1 times 5 dy dx plus 1 times 2 times 1 equals 8 dy dx plus 3. Alright, I'm gonna erase this way. Okay, it's fine. Okay. So yeah, solve with dy dx, and you get negative 3 dy dx equals 1. Well, no, you get 3 minus 3, so minus 5. Right, you know, boom. Now we get negative 1. Okay, and then you divide by 3. Yes, you divide by 3, so you get dy dx is equal to negative 1/3. So then, you're not done yet. We now have our slope of the y at the tangent line. But in order to use this for a point, we have to put into a point slope formula, which was y minus y1 equals m times x minus 1. You know, 7th grade, right there, boom. So you get y minus 1 equals negative 1/3 x1, 1/3 minus 1. So you get y equals negative 1/3 x. And then you get plus 1/3, and then so you get plus 4 thirds. And that would be your tangent line at the point 1, 1,